We're going to go through how to find the transformation represented by this matrix. You'll learn almost nothing if you're just watching and listening to me, so take every opportunity to pause the video and do the next bit by yourself. Obviously, if you've already done that bit and you're just checking whether you got it right, do keep watching. So pause the video now and have a go at this example. The strategy is to take the unit square as our object, that's this square here, transform it using the matrix and see what the image looks like. Pause now and have a go. If you need more detail, here are the steps. Make sure you've had a really good go before you resume the video, and note it's important to label the object and the image when you're making the sketches. For step 1 you should have done this. Here's the unit square. It's labelled O, A, B, C. The labels are important. Have a go at step 2. For step 2 it's this matrix multiplication. The image matrix is this. So now pause the video and do step 3, which is to plot and label the image. Your plot should look like this. O' is still at the origin. A' is at the point down here, 0, -1. B' is the point 1, -1. And C' is now the point 1, 0. So if we join those up, that's the image. Now pause the video and see if you can do step 4, which is by comparing the object and the image, your diagrams, write down what the transformation is. You should be able to see that the transformation is a rotation about the origin through 90 degrees clockwise. Here's a really important point. Can you see that if we didn't have the labels on our diagrams of the object and the image, we might be completely misled? It could look like it's a reflection in the x-axis. That's why it's so important to label both your diagrams. Okay, this is very badly laid out. We should always be working vertically down the page, but I wanted to fit everything onto one screen. Have a look at the 4 steps now, review them in your mind and make sure that you really understand the whole lot before you move on. If necessary, watch the last couple of minutes of the video again. That wasn't a particularly difficult method, but there's a shortcut we can learn. You're going to need to do some thinking, so you'll need a pen and paper. I want you to have a look at a couple of features of this calculation. First of all, the image of the origin was the origin. Is that a coincidence, or would it always be like that? And what about the point 1, 0? The image of that point A looks like it's the first column of the transformation matrix. Is that a coincidence? And what about the point C, 0, 1? The image of that point is the second column of the matrix. Is that a coincidence? Pause the video and have a think about it. See what you come up with. What you should have found out is that if you take any transformation matrix and transform the origin, you'll get the origin. So there was no coincidence. That would always have to be the case. Pause once more and just check the other 2 points. Similarly, no matter what the transformation matrix is, if you transform the point A, 1, 0, you're always going to get the first column of the matrix, so no coincidence there. If you transform the point C, 0, 1, you're always going to get the second column of the matrix, so that wasn't a coincidence. It had to be that way. We can even go one step further. If you transform B, the point 1, 1, you can see by doing the matrix multiplication for yourself, you're always going to get A plus B, C plus D, no matter what the transformation matrix is. So here's a summary of our shortcuts. Whatever the transformation is, the origin stays in the same place. The first column of the matrix tells us where the point 1, 0 finishes up, and the second column tells us where the point 0, 1 goes to. And the fourth point, B, completes the shape into a parallelogram. The best way to prove that formally is to use vectors from C4. So that means we don't need to do matrix multiplication at all. I hope you've understood all of that theory. If there's anything you're not sure about, go back and review parts of the video. You may need to do it a few times. It's really important to actually understand. But what we're going to do now is repeat the example in the way that you would in the exam, taking advantage of what we've just learned. This is all you'd have to write. We can see straight away that the point A, 1, 0, would go to 0, -1 because of the first column of the matrix. We know that the point C would be transformed to 1, 0, the second column of the matrix, and we draw 2 diagrams. The object looks like this. Remember, we've got to have our labels on there to avoid confusion. And the image will look like this. The origin stays in place. We now know where A' is and we know where C' is. And B' always completes the parallelogram. In this case, the parallelogram is a square. So all we need to do for working is that, and we now write down the answer. It's a rotation about the origin through 90 degrees clockwise. Everything we've been doing so far has been about being given a matrix and working out what transformation it represents. Now we're going to look at what happens when you're given a transformation and you want to work out which matrix represents it. We're using the same theory as before. So here we've got an enlargement, centre of the origin scale factor -2. If the scale factor was +2, the image of A would be here, twice as far from the centre. But it's -2, so A' is there. Similarly, the image of C is here, and we can write this working. A10 is transformed to -20. That's going to give us the first column of the matrix. And the second column of the matrix is going to come from the image of C. So the answer is going to be -2, 0, 0, -2. So quick.